All right, greetings everybody. Welcome to the second part of the video for section 4.2, continuing on with our study of the graphs of exponential functions, and matching graphs to equations and vice versa. Okay, so in the last video we learned about how, well, one of the general forms for the equation of an exponential is f of x equals a times b to the x, and we learned how these values a and b relate to the graphs of these functions. So down below over here I've got 6 functions, and I've got 6 equations over here on the left and then 6 graphs over here on the right. And what we need to do is match the graph with the equation. So to help us with that, I'm going to label these as the yellow one there is A, this is B, C, the green one is D, the red one is E, and then the last one, which I think is black, is F. We need to figure out, again, match these with equations over on the left. Now, when I look at the graphs, I note that one of the equations that stands out is the blue one there, because it's the only one whose vertical intercept goes through the point 0, 3. And we know that the vertical intercept relates to the value a. So that tells me over here in my list of functions, I'll be looking for a function that has a value of a equal to 3, and well, there's only one option for that. That's g of x here. So we know that that is going to be the letter C. All right. Let's look at another couple we can identify. I should also say, notice I am not using my calculator at all for any of this. I'm doing this based on my knowledge of the shapes of exponential functions. Okay, the next 2 shapes or the next 2 graphs that stand out to me are A and B. Because notice they are the only ones of the 6 that decrease from left to right. And we know that an exponential function will decrease if the value for B, the value right here, is between 0 and 1. And when we look at our list of equations over here, the only ones with value of B between 0 and 1 are k of x and L of x. So we know that A and B have to do with those 2. And to figure out which one is which, what I'm going to do is think about if I were to plug into 1 into each of these equations. So for k of x, if I plugged in 1 for x, I would have 1/2 to the 1, which is just 1/2, which means that graph needs to pass through the point 1, 1/2. Well, when I look over here on my graph at an input value of 1, the picture that looks like it's passing through an output value of 1/2 is that yellowish one, so it looks like that should be letter A, which tells us that L of x should be letter B. And we could check that by seeing that if we input 1, and for x here, we'll have 1/3 to the first, which becomes 1/3. So this graph should pass through the point 1, 1/3. And when we look at the purple one here, it looks like it does that, right? Looks like if we go over to an input of 1, we go through an output of 1/3. All right, we got half the graphs down already. Just cruising right along. Okay, for the remaining ones, it's kind of hard to, we can't use any special features like they're increasing or decreasing or the vertical intercept because they all go through the same vertical intercept. But we can also do that trick that we did for k of x and L of x. So for f of x, the first one up here, for example, we note that if we plug in 1 for x, we'll have 2 to the first, which is just 2. So we know that for an input of 1, we should get an output of 2. So if we check that over here on a graph, input of 1, output of 2, that looks like that is the graph F. For H, we do a similar thing. Input 1 for x here, we get 3 to the first, which is just 3. And we notice that the one that goes through the point 1, 3, well, that looks like it's the graph D there, which then means the only one left for e to the x there is going to be E. It's appropriate that that one is E. Let's also think about if we can reason through that. Remember the letter E, or the number E, is equivalent to about 2.718. So if we plug in 1 for x there, we'd have e to the first, which would be e, or 2.718, which means this graph should pass through the point 1 about 2.718, and it looks like it does. Okay. So our matching here gives us FCDEAB. And again, notice we did that without the use of a calculator. All right. Let's also now talk about transformations of exponentials. And here when we're talking about transformations, we're really talking about vertical shifts, shifts up or down. So if we have an exponential function that's been shifted up or down, we can figure out its equation by the form f of x equals a times b to the x plus c. So notice now we've got something being added here at the end, which it should make sense that that means a vertical shift up or down based on our studies from chapter 1. And notice that shifting the function up or down, what that changes most notably about the function is where the horizontal asymptote is. So notice now the horizontal asymptote is going to be at y equals c, or we could say g of x equals c. But it's going to be a constant function where the constant output value is whatever is being added to the end of the function. Okay, and I will reiterate again, we use this form when the horizontal asymptote of our exponential function is not at y equals 0, or is not along the horizontal axis. Okay. The other thing about this form is shifting up or down. What it changes about our equation is this value a now is no longer where our vertical intercept happens. Okay, so because we've been shifted, that no longer works. Okay, so let's take a look at that. So here we have an exponential function over here on the right. They didn't tell us what it was called, so I'm going to call it f of x. And we're going to find the equation here. And notice, first of all, we can tell that this function has been shifted up or down, because if we look for the horizontal asymptote, and it looks like that would be right here, notice that it is not along the horizontal axis, right? It's at that value -4. So that tells us that we're going to use this form, f of x equals a times b to the x plus c. And what we need to do is find the values for a, b, and c. Now finding c is fairly straightforward because, as we saw on the previous slide, the value for c comes from the horizontal asymptote. So notice that our horizontal asymptote goes through -4. So that tells us this function will have the form f of x equals a times b to the x minus 4. So put in -4 for the c value. And now we just need to find a and b. Now, as I mentioned, we cannot just say that a is -1 and equal to the vertical intercept value. That's not going to work here because we've been shifted. If it had not been shifted, that would work, but it's been shifted. So here's what we're going to do instead. Is we're going to find some points on the graph that are easy to read. So for example, this one right here, which is 0, -1. And this one right here, which looks to be 1, 2. We're going to plug them into the function and see if we can solve for a and b. So I'm going to start with 0, -1. So from that, I see that my output value is -1 when my input value is 0. So it'll give me -1 time, equals a times b. I plug in 0 for x, minus 4. I have -1 equals, and b to the 0, recall that anything to the 0th power is just 1. So this part here, this a times b to the 0, just becomes a times 1. But a times 1 is just a. So we have -1 equals a minus 4, and we can add 4 to both sides. And now we have our value for a being 3. Okay? So now we have both the values for a and for c. So let me plug that in here. So we know the value for a, this is going to be 3. Oops. right? And then we still have to find the value for b, so we can use our other point, the 1, 2. So we'll plug that in. Again, it tells us that for an output of 2, we have the input value of 1. Okay, so we have 2 equals 3 times b to the first minus 4. We can solve for b, so add 4 to both sides. So 2 plus 4 gives me 6 equals 3 times b to the first is just b. We can divide by 3 on both sides, and we do that, we end up with b equals 2. So now we have the value for b as well. We can plug that in to our equation here. And we see that our equation then comes out to be 3 times 2 to the x minus 4. Okay? And do be careful, if you're doing calculations with this, the x is only attached to the 2. Okay, it's 2 raised to the x power, not 3 times 2, and then the answer raised to the x power. All right, and that there would be our answer for the equation here. And you could also graph that on your calculator to see that it matches the picture we have here. All right, that's all for section 4.2. Thank you for watching.